Everybody, we are back to normal notes for a little bit, I guess. I decided for this section, I thought the note section would be the best way to go about this. It's a 3-page note section, so you can expect 1 page today, 1 tomorrow, and 1 the next day. So we have kind of just started talking about logs and just kind of what they are. Today we're going to talk more about what things we can do with them, like algebraic things we can manipulate logs in order to solve and expand different logarithmic equations. Before we start that, we do need to kind of go over just some review properties, I guess. And to do that, it just helps us to be able to do things without a calculator. So in this first one, so I'm starting here, I'll go down and then I'll start back over here. In this first one, it says log of 100. So it doesn't really have a base, but remember, if it doesn't have a base, we use log base 10. So this is log base 10 of 100. And it equals nothing, so we got to set it equal to x. So if we want to put this in logarithmic form, we would say 10 to the x power equals 100. So 10 to what power is 100? You should say, well, that's easy. That's 2. Oh, good. Mindy's barking. Just a second, people. Come on. Come here. Go. 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 Okay, sorry. Okay, so for the next one, we have log base 3 of 27. And again, it's not set equal to anything. So we are going to say equals x. That would be 3 to the x power is 27. Look at your perfects card. 3 to what power is 27? You should say, well, that's easy. That's 3. Okay, next up we have ln of e. So ln, natural log, and that's the base e. So log base e of e, and we set it equal to x. So e to the x power, oh my goodness, Mindy. This is fun. Go. Come here. Go. 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 Okay, she is now officially locked in her bedroom. That should not be an issue. Sorry about that. Okay, so e to the x power equals e. Again, I'm right here. E to what power equals e? Well, any number to the first power is itself. So that one is just 1. Okay, next up, for this next one, I think we don't need to write this write it out in exponential form. You should think of this as 5 to what power is 125? Well, 5 to the third power is 125. This next one, we might have to actually think about it. So we have a decimal. So this is log base 10 of 0.1 equals x. 10 to what power is 0.1? Well, you might be saying, well, it's going down, it's getting smaller. That must mean we need a negative exponent. And remember, 0.1 is really 1 over 10. So how do you get 10 to look like 1 over 10? You put it to the negative 1 power. Okay, next up, 2 to what power is 32? I'm up here. 2 to what power is 32? You should say, well, easy. Look at your perfects card. That's 5. Next up, log base 9 of 1. 9 to what power equals 1? Any number to the 0 power is 1. Next up, this one should be easy as well. Log base 12 of 144. 12 to what power is 144? Should say, well, that's 2. Okay, next up, log base 2 of 1 over 8. Okay, so again, we're getting smaller here. So you know it should be a negative, so it equals x. 2 to what power equals 1 over 8? Well, we go negative to make it a fraction. And then 2 to what power is 8? Should say 3. Okay. Now, last one, log base 4 of 2. You should notice a relationship here. 4 to the x power equals 2. But this one isn't going to be negative. I know it's going smaller, but a negative is to flip it and make it a fraction. This isn't make it a fraction, it just gets smaller. So what's the relationship between 4 and 2? Well, the square root of 4 is 2. So how do you say a square root as an exponent? You put it to the 1/2 power. Okay, so that was just a quick review of kind of evaluating. Now we're going to use that top portion and this next portion for the problems on bottom. So the product property. If we have log base b of x times y. So if we are multiplying two things together inside of a logarithm, what we can do is we can pull this apart, put the x over here, the y over here. And this would turn into log base b of x, log base b of y. Now, instead of multiplying in the middle, that multiply turns into adding when you pull it apart. So when you expand it, when you go out, expand means to make it bigger. From here to here, I made it bigger. When we expand, when we start with multiplying in the middle, it becomes adding when we pull it apart. That's for product. Product means multiply. Okay, next up, we have the quotient property, log base b of x divided by y. Okay, same thing. We're going to expand this out. We're going to say it is log base b of x. X is on top, so it goes on the left. Log base b of y. Y is on bottom, it goes to the right. Now here, we were dividing. What do you think dividing is going to turn into? This was divide. It's going to turn into subtraction in the middle. So division becomes subtraction when we pull them apart. And you might be asking, well, how the heck am I turning just random multiplication into addition and division into subtraction? Remember, logarithms are exponents. So when you have like x to the 5th times x to the 3rd, it becomes x to the 8th. When we're multiplying, we add exponents. Oh, weird. When you're multiplying, you add. When we are dividing exponents, if we had x to the 8th over x to the 5th, well, which one's bigger, top or bottom? Top by how many? 3. How'd you get 3? 8 minus 5. So we started with division and it turned into subtraction. It's really the same concept, but now we're just applying it in a different way. Okay, last but not least, the power property. This one is, I wouldn't even say it's confusing. So if we have log base b of x to the y power, what we do with this y, oh boy, I want to undo that. What we do with this y is it comes out front and it becomes multiplication. So this is y times log base b of x. Okay, I will show you some example kind of ways to apply this on the bottom. But if I were you, I would write this down on like a little piece of paper just to have it handy at all times. I would write these down. Or screenshot them, keep them on your computer, something. Because we're going to use these a ton the next 3 days. Okay. 6 problems here. It says, use the logarithmic properties, so the properties above, to evaluate. Oh boy. I am riding the struggle bus this morning, people. I apologize. So we are evaluating each of these. So what does evaluate mean? That means get a final number answer. Okay, so number 1, it's log base 6 of 6 times 216. Key there is times. What we're going to do is we're going to use the product property. We're multiplying. So I can pull this apart to be log base 6 of 6, log base 6 of 216. And when I pull it apart, multiplication becomes addition. Well, how the heck does that help me? It got bigger. I'm trying to get a final number answer, Mr. Elder. How does that help me? Well, we're going to combine what we did up here, not to the middle, to solve this. So log base 6 of 6, that's saying 6 to what power is 6? Well, that's 1. What's this part saying? Log base 6 of 216, that's saying 6 to what power is 216? Well, that's easy. 6 to the Okay, don't look at your perfects card. 6 to the third power is 216. What's 1 plus 3? Answer is 4. That's it. Okay, on to number 2. I'm going to try to chunk this out so I keep it somewhat clean. Okay, we have log base 2 of 8. So what the heck do we do here? Well, you might notice that there is an exponent there. So we're going to use the power property. This 5 is going to come out front and become multiplication. So now it's 5 times log base 2 of 8. We can actually simplify this down further because 2 log base 2 of 8, that is saying, well, 2 to what power is 8? Well, 2 to the third power is 8. Now, 5 times 3, final answer, 15. Bang. Okay. On to number 3. Okay, we are dividing here. Dividing. What property are we going to use? Probably the quotient property. Okay, so quotient property says, it's this one. Sorry, I'm zooming in and out here. It says if I have x over y, so 1 over 100, I separate apart log of 1 minus log of 100. Remember, this is log base 10 and log base 10. So 10 for this first part, 10 to what power is 1? Any number to the 0 power is 1. Minus 10 to what power is 100? Well, 10 to the second power is 100. 0 minus 2 is negative 2. And that makes sense because this is technically log base 10 of 1 over 100. So 10 to what power equals 1 over 100? Flip it, that's where we get the negative from. 100 is 10 squared, so we get negative 2. Okay, if I were you, I would maybe pause the video and try the next 3 on your own. Okay, I'll try to make another little wall here. I know I should have spaced this out better. My apologies, people. So pause the video, try the next 3, and then resume the video and check your answers. So number 4, we are multiplying here. So multiplying, when we pull those apart, look at the product property up here. So when you pull them apart, you add. So this is log base 2 of 16 plus log base 2 of 32. That's saying 2 to what power is 16? 2 to the 4th is 16. 2 to what power is 32? 2 to the 5th power. I'm still adding between. 4 plus 5, 9. Okay, number 5. You might notice, hey, I got an exponent here, so I'm going to go bring this sucker out front. 2 times log base 3 of 27. Now you ask yourself, 3 to what power is 27? That should be 3, and you have 2 times that 3. Should get 6 as the final answer. Okay, last one here. We are dividing. So when I divide and pull it apart, it becomes subtraction. So I have log base 6 of 36 minus log base 6 of 216. This is saying 6 to what power is 36? This is saying 6 to what power is 216? 6 squared is 36. 2 minus 6 to the third power is, I should color code that better, sorry. That's why I got a little confused. 6 to the third power is 216. 2 minus 3 is negative 1. Okay, your final answer is negative 1 for that. I will post an assignment. I apologize for my dog being obnoxious. Yeah, if you have any questions, feel free to